Let's take a look at these two review problems that are more conceptual. So in other words, don't forget your definitions for the exam. Uh, the first problem here involves just simply knowing the terms. So let me just kind of just say these. The formal definitions can be found in the textbook and also in the lecture notes. The null hypothesis is the idea that whatever difference that you see is simply due to chance. That yes, there might be a difference between a difference between the proportions or the averages. However, the difference that is observed is plausibly attributable to chance. The alternative hypothesis would state, to the contrary, that the difference that observed is a real difference that is not plausibly attributed to chance. So that's the null and alternative hypotheses. The critical value is basically the cutoff value between where I decide to reject the null hypothesis and where I decide to fail to reject or retain the null hypothesis. So the critical value is the cutoff between where I make this decision. There has to be some cutoff someplace. If the critical value is too big, I'm sorry, if the test statistic is too big, then I would decide to reject. If it's not too big, I would decide to retain. Somewhere between those phrases, too big and too small, is the critical value, the place, the cutoff word between I make the decision. The rejection region basically means all possible values of the test statistic for which I would reject the null hypothesis. Now, I kept using the word decide. It is always possible to make the wrong decision, and so there are two ways of making the wrong decision. A type 1 error occurs when I reject the null hypothesis when the null hypothesis is true. In other words, I think the alternative is true, but the null is true. A type 2 error is the reverse, where I fail to reject the null hypothesis when the null hypothesis is false. So I think that the null is true, but the alternate is really true. The power of a test is 1 minus the probability of making a type 2 error. So we typically denote by beta the probability of making a type 2 error. So the power of the test is 1 minus beta. In other words, it's the probability of correctly rejecting the null hypothesis when the alternate is true. The significance level is the probability of making a type 1 error. So the probability of rejecting the null hypothesis when the null is true. And finally, the observed significance level, that is a fancy word for the p-value. That's the probability of seeing a test statistic as extreme or more extreme than the one that was found in the test. So the formal definitions can be found in the textbook. That's a brief verbal definition of these 9 terms. Finally, for problem 3.2, the p-value is determined to be 0.5. The best conclusion is that the null hypothesis is plausible, so option number 5. Number 1 and number 2 are false because the word definitely, so there's no such thing as being definite in a hypothesis test. There's always the possibility of making a type 1 error or type 2 error. Also, this is a false interpretation of the null hypothesis, saying that there's a 50% chance that the null hypothesis is true. The null hypothesis is either true or it's false. There's no such thing as a 50% chance of the null hypothesis being true. 4 is almost right, except that this part is too blatantly decisive. So we'll simply say that the null hypothesis is plausibly true as opposed to simply definitively true.